guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we'll be having a look at the quotient rule under the topic of differentiation. Now before I begin, I will strongly advise you guys to go over two of my previous videos. One is the basics of differentiation and the other one is the product rule, as I believe that those two videos will be really helpful for you to understand this particular topic. So without any more delays, let's begin. So we are having a look at the quotient rule. Now again, quotient rule under the topic of differentiation is more like a subtopic. It's not a topic on its own, but it's a sort of skill or weaponry you should have in order to answer particular questions. A lot of questions will require you to undergo the method of quotient rule, so it's a very valuable trick to know. Now, as you know, quotient is also known as the answer to a particular problem that involves division. The answer of a multiplication question is called product, the answer of a addition question is called sum, and the answer of a subtraction problem is called difference. Likewise, the answer for a division question is usually called the quotient. Now, what exactly is the quotient rule? If we recall from our previous video when we had a look at the product rule, we said that when two different functions, u and v, are being multiplied, instead of opening the brackets out or whatever the case may be, we use the product rule, which is known as dy dx, that's the product rule, equals to v du dx plus u dv dx. However, the quotient rule is slightly different. The quotient rule is as follows. We have d, in brackets we're going to have u over v, because this is what we're essentially differentiating. I'll come back to that in a moment. So d u over v dx is equal to v du dx minus u dv dx all over v squared. Now again, what's our u and what's our v? There are two separate functions that are being divided. In this case, or in most cases, the way we would represent a formula is when our u is being divided by v. So whatever the function is the numerator, we call it u, and the function that's denominator, we call it v. Now, you can write it like this, or you can simply just erase the u over v and you can leave it as dy over dx, because essentially all of this will be equated to y. This will be equated to y equals, so you can have it as dy dx as well. It's perfectly fine, but this is the formula that needs to be noted, because in most exam boards they do not give you this formula. You have to know it by heart, and if you compare it with the product rule, it's almost the same. Not exactly, it's just that in the product rule we have v du dx plus u dv dx. So to go from the product rule formula to the quotient rule formula, we just change the plus over here to a minus, and we have that as the numerator, and we add a denominator, which is v squared. So if it helps you to remember that way, you can go by that as well. The important thing to note is that in the quotient rule, your v, the v squared, the v part of the v squared, and the v over here is always going to be the denominator in the original equation. So suppose I have something like, for example, y is equal to ax all over cd, and if I want to apply the quotient rule, my u will be the numerator, in which in this case is ax, and my v will be the denominator, which in this case is cd. Right then, let's look at our first example. The first example asks me to differentiate y is equal to 5x plus 1 all over 3x minus 4. So I've been asked to differentiate this. First things first, always a great idea to write down the formula first. Sometimes in some exam boards it does help you get a mark, in some it doesn't, but I always advise it to write down the formula. It helps your work look a lot more neater and organized. So dy dx is equal to v du dx minus u dv dx all over v squared. Now you can go right here to the question and just label our u's and v's. This is our u, the numerator, 5x plus 1, and our v is 3x minus 4, which is the denominator, v. So just plugging in our values and the corresponding representatives are v, that is the denominator, which is 3x minus 4, so 3x minus 4, that is being multiplied by du dx, and our u is 5x plus 1. Differentiating 5x plus 1, we get 5, minus, and then we have u, which is 5x plus 1 being multiplied by dv dx, and the derivative of v, 3x minus 4, is 3. All of this all over v squared, which, and our v is 3x minus 4. 3x minus 4 squared. There's no need for us to write it as like this, 3x minus 4 and then 3x minus 4, and then we now go and start to, expand and all. That is much of a waste of time. You can just leave your denominator like it is, 3x minus 4 squared. There is rarely ever going to be a question that's going to ask you to just perform the quotient rule. As I said, quotient rule is more of a topic that's used in other topics. For example, a very good example would be that you're doing quotient rule while trying to find the stationary points of a particular curve. And when you're trying to find stationary points, you equate it to 0. And when you equate all of this to 0, this will eventually go away. It won't exist again, because if you cross multiply it, it won't be there. So that's how it can be at times. And if not like that, you might be equating it to a particular value given from the question. Let's say, for example, equals to 4 over 6, then you maybe cross multiply and then find a particular value for x. It could be any case. But in this particular video and this sole video, we're just going to leave it as it is simplified. Now the next step, we just expand our brackets. 3x minus 4 and expand that by 5, so we have 15x minus 20, and I'll show you in a moment why I'm still keeping that in brackets, minus 5x plus 1 into 3, that's 15x plus 3, close brackets, all over 3x minus 4 all squared. Now the reason I kept these two in brackets is because it helps me to deal with the signs. We have a minus in between, and as I say, minus is the most dangerous sign in mathematics. It can easily tamper your answer from one place to another, and you have to be very careful. By putting this in brackets, right, what it does, it helps me to just inflict this sign onto the next, so I know this becomes minus 15x in any case, and this would become minus 3 because the minus is affecting it. If, for example, this was a minus here, but I had a minus 3 inside instead of a plus 3, then the minus 3 times the minus 3, then the minus times minus 3 would give me a plus 3 in the end. In this case, it's just minus to plus 3. So we collect our like terms. We have 15x over here minus 15x over here. So 15x minus 15x cancel out, so we don't have any x's at the top. And then we have minus 20 minus 3. That is minus 23 all over 3x minus 4 squared. And that is the final answer for that example. Right, on to the next example. We have been asked to differentiate y is equal to 6x minus 6 all over 3x cubed plus 2x squared. So first things first, we write down our formula. Dy dx is equal to v du dx, v du dx minus u dv dx all over v squared. We have our v to be the denominator, we have our u to be the numerator. Now we go ahead and do the necessary steps. V into the u dx, our v is 3x cubed plus 2x squared, so in brackets 3x cubed plus 2x squared into the derivative of u, so the derivative of 6x minus 6 is 6, minus u dv dx, so 6x minus 6 into the derivative of v, which in this case would be 9x squared plus 4x all over v squared. Now forget the v squared, a lot of people do tend to forget it, but always keep it there, all over v squared, which is 3x cubed plus 2x squared all squared. Right, so we can collect our like terms from the numerator, or first actually we should expand it, sorry. First, upon expansion, we get 18x cubed plus 12x squared. Again, I like to put all of this in brackets. For some people it might not work, you might like it without the brackets. It's totally up to you, whichever one you're comfortable with. Please only and only do that way. Expanding the next side, we have 6x into 9x, that's 54x cubed. Sorry. Plus 24x squared minus 54x squared minus 24x 6 squared. Yeah, looks right about correct. All over 3x cubed plus 2x squared all squared. Now we can go ahead and collect our like terms. 18x cubed minus 54x cubed, that should be minus 36x to the power of 3. 12x squared minus 24x squared gives me minus 12x squared, and minus 12x squared plus 54x squared, because we have a minus over here and then a minus over here as well. So minus 12x squared plus 54x squared, that should give me 42x squared. So plus 42x squared, and we only have one term with x, and that's minus 24x. All over 3x cubed plus 2x squared all squared. You can leave your answer like this, or you could go ahead and just simplify if you want to go the extra step. You can say minus 6x into 6x squared minus 7x minus 4. All over x cubed into 3x plus 2 all squared. Yeah. Sorry, no, minus 4. I think it should be plus 4. Yeah, plus 4. So that is the these two are the final answers for this particular example. Any of these two would be just fine. Right, and on to the final example for the quotient rule. This asks us to differentiate y equals to 3x minus 9x to the power of 4 all over x to the power of 3 plus x. Right, so again we do the necessary dy dx, we write down the formula. Dy dx is equal to v du dx minus u dv dx all over the v squared. So our v in this case, as we know, is the denominator. This is our v and this is our u. So v, that's x cubed plus x cubed plus x into du dx, so we differentiate 3x minus 9x to the power of 4, that should be 3 minus 36x cubed. Yeah, 3 minus 36x cubed minus u dv dx. Our u is 3x minus 9x to the power of 4, and that's going to be multiplied by dv dx. Differentiating our v, we get 3x squared plus 1. All of this over v squared, and our v was x cubed plus x, so we can just do x cubed plus x all squared. Right, then we continue. We can expand the brackets first and foremost. So upon expansion for this first part, we get 3x cubed minus 36x to the power of 6 plus 3x minus 36x to the power of 4 minus, and then the next side, the next part rather, we get minus 9x to the power of 3 plus 3x minus 27x to the power of 6 minus 9x to the power of 4. And remember, all of this over x cubed plus x all squared. Just write that 2 again. Okay, now we can go ahead and collect the like terms. In terms of the powers of 3, we have 3x to the power of 3 minus 9x to the power of 3, so that gives me minus 6x to the power of 3. I have minus 36x to the power of 6 minus 27x to the power of 6, so this becomes minus 36 plus 27, and that gives me minus 9x to the power of 6. And then I also have plus 3x here, plus 3x minus plus 3x, this will cancel out, 3x and 3x will cancel out. And then lastly I have minus 36x to the power of 4 minus that becomes plus, so minus 36 plus 9, so that's minus 36x to the power of 4 plus 9x to the power of 4, which is minus 27x to the power of 4. And all of that over x cubed plus x all squared. And in this case, we're just going to leave our answer like that. Now, just by looking at this, I could say that if this sort of equation was involved, in a question that where you have to equate this to a particular value, maybe 0 if it's stationary point, or a particular gradient value, then I could see that it involves disquieted quadratic equations, which you can go over in one of my previous videos, because I can see power 3 and I can see power 6, and you might have been asked to solve this quadratically. So that is the final answer for that example, and that indeed brings us to the end of this video. Thank you for watching. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe. Thank you for watching, guys. Have a nice one.